suggested by you is as follows. Here we need to find the voltage regulation of transformer at full load and at 0.7 power factor lag. Okay, and these are the details given in the question. So how to proceed is first let's write what is voltage regulation. So voltage regulation of a transformer is given as Z per unit cos theta minus phi. Okay, so this Z per unit is the per unit impedance of the transformer. Okay, and this theta is the angle which this angle. Okay, if this is Z per unit, this is X per unit, and this is R per unit. So the angle theta, or you can say the impedance angle uh, of the transformer. Okay, and phi is the power factor. So power factor is already given to us, and we need to find the other values. Okay, so how to calculate Z per unit? Okay, so in this expression you can see Z per unit is variable, also theta is variable. If we are able to find these two, then we can find the uh, regulation of the transformer. Okay, so how to find Z per unit? You can see here that the data for the short circuit test is given. Okay, so short circuit test is given. So what you can do is the Z equivalent. Okay, Z equivalent will be equal to, equivalent means both uh, primary and the secondary side. Z equivalent will be 20 over 12.5. Okay, this will be your Z equivalent. Okay, so this is in ohms, but what we need is we need in per unit. So what we need to do is we need to define the base, or we have to divide this by base of the base impedance of the transformer, and then we will get our Z per unit. Okay, but here the impedance of the transformer seen from primary and the secondary side both will be different, but as this is performed on high voltage side, or the short circuit test is always performed on high voltage side, so we need to find the impedance from the high voltage side. Okay, so the base Z base will be equal to the whatever is our so how we can calculate this is we can write v square by Z base is equal to the power base. Okay, so the power is 5 kilowatt. I am writing it as 5000. Okay, so this is also given in the question. Okay, I can see here this is given in the question, so you can write now v squared is 400 squared over Z base is equal to 5000. Okay, so from here you can calculate the Z base. So Z base will be equal to 5000 over, or it will be equal to 400 squared over 5000. Okay, 400 squared over 5000. Okay, so now you can calculate your Z per unit. Okay, so now Z per unit will be equal to Z equivalent over Z base. Okay, so what it will be 20 over 12.5 over 400 squared over 5000. Okay, now if you do all this calculation, you will get, what you will get is 0.05. Okay, this is your Z per unit. So now we have got Z per unit. Okay, now we need to find theta. So how to find theta? Let's do again. So how we'll find theta is, so remember theta is this thing. Okay, this is theta, this is Z per unit, this is R per unit, and this is X per unit. Okay, so now you know how. So if we calculate R per unit, then we can use cos inverse Z R over Z, R per unit over Z per unit is equal to theta. Okay, so we can easily calculate R per unit. Okay, how, what is R per unit? R per unit is the losses, the I square R losses. Okay, and divided by the full capacity of the transformer, that is our R per unit. Okay, so R per unit is 175 over 5000. Okay, this is our R per unit. Okay, so if you calculate this, this comes out to be 0.035. Okay, this is your R per unit. Okay, always remember that this is equal to the losses which are obtained during the short circuit test, and the power, the apparent power of the transformer. Okay, so you have to be just careful here that this should be calculated at the current, the rated current of the secondary. And if you calculate from the secondary side or from 400-volt side, you will see that if you do the secondary full load current, it will come out to be 12.5 amperes. So you can use directly this formula. Okay, so now we have both Z per unit and R per unit, so we can calculate theta. So cos inverse R per unit over Z per unit is equal to cos inverse R per unit is 0.035 over 0.05. Okay, now you can calculate easily from here what is your cos inverse zeta, cos inverse at this angle, and it comes out to be 45.57. Okay, so this angle again we have calculated. Now let's again write the formula for regulation. Now the formula for regulation is Z per unit cos theta minus phi. Now phi is cos inverse 0.7. So what is so theta we have already calculated. This is our theta. Now phi is equal to cos inverse 0.7. So which is again equal to 45.57 degrees. So you can now substitute these values here. So Z per unit is 0.05 cos of 45.57 minus 45.57, which is equal to 0.05 cos of 0. Okay, 0 degrees. So now cos of 0 degrees is 1. So you get 0.05. Okay, now in percentage this is equal to 5%. So our option D is correct. Okay, so this is how you have to proceed with these kinds of problems. So thanks for watching.